All right, kids, the two opening proofs, I'm not going to do those here. Again, I'll post them on Canvas after our in-class Zoom lesson. But if you feel like doing this on your own, again, this one here is 8 steps. There's nothing new in these top two problems. So that's why I'm not going to, let's just practice. 5 steps for that one. All right. Now what you're going to see down here, let's take a look here. We have AM congruent to AN. All right. And AT is a median. We have to prove angle M congruent to angle N. Well, we can say that MT is congruent to TN if median then divides opposite side into 2 congruent segments. Now, of course, we have AT congruent to AT. So that's reflexive. And we can prove that triangle AMT is congruent to triangle ANT. And that's by SSS, which allows us to then say that angle M is congruent to angle N by what? CPCTC. So proof is super simple, but what it's going to do is going to lead us to a shortcut theorem. You see, when you're given that AM is congruent to AN, that means that this triangle is isosceles. So whenever you have an isosceles triangle, you can always drop in a median to the base from the vertex, and that's going to, we're going to always end up having 2 congruent triangles by SSS, and then these angles down here are going to be congruent. So instead of going through all that business, we have some different theorems that we can use as a little shortcut. And this is on your gold sheet, and it's number 27A, right? So in other words, and we're going to use the shorthand versions, which is much better. In other words, if this is what we just did, right? If we have 2 sides of a triangle congruent, then the base angles opposite those sides have to be congruent. This was 27A. And then 27B is the converse of this. If you have 2 base angles, then of course the sides across from them are congruent. So this is really gonna, and it's best to just write this. And what this means is if sides, then angles, if angles, then sides. Now, if you also look, we talked about this the other day. There's 4 reasons on your gold sheet, number 28. And that's all just about isosceles triangles, if, and you can use symbols here as well. If 2 sides congruent, then the triangle is isosceles. If 2 angles congruent, the triangle is isosceles. Of course, if triangle's isosceles, then 2 sides congruent. If triangle is isosceles, then 2 angles are congruent. So you can use all this shorthand stuff. Saves us a lot of precious time. So let's go to the back side. And take a look at this problem here. So we have EDC is isosceles with base EC. So that means that ED is congruent to CD, right? And then it says BCD is isosceles with base BD. That means this is congruent to that. Oh, okay, we got to be careful with this. So first, let's go ahead and say that ED is congruent to CD. And then we're also going to say that CD is congruent to BC. And again, if triangle isosceles, then that gives you sides. Okay. Now I hope you realize we got CD referenced twice there. So ED must be congruent to BC. It's very easy to forget to do that. If segment's congruent to the same segment, then congruent. So we're kind of caught up to our tick marks now. Hope you see we can prove, we're going to prove this triangle here congruent to its overlapping twin over here. Okay. Now remember, I haven't marked this last given yet. I need to do that. I forgot about that. ADC. And so now we can say reflexive, DC congruent to DC. And then we can get those two overlapping triangles congruent by SAS. So EDC congruent to BCD. Now, what are we going to take from that to help us prove EF is congruent to BF? You see, EF is just part of the side of that triangle. But what we could do is take this entire thing. We're going to take two CPCTCs. We're going to take this entire thing, EC congruent to BD, okay? But then we're also going to want, and you'll see why in a second, we're going to want to also say that angle ECD, this little, I'm going to do this in, this will come back in a second, I hope. Takes time. So I'm going to do this in a different color. I'm going to say angle, and this little sliver angle, you see, that is congruent to that from CPCTC as well. So angle ECD is congruent to angle BDC. And this is all from CPCTC. Now, I hope you see where we're going with this. You see, look at this little triangle down here now. We have the base angles congruent. That means the opposite sides, FD, is congruent to FC. And that's from if angles, then sides. And now we just said that FD is congruent to FC. Remember earlier we had these holes congruent. So now we can say EF, but remember it's not division. This is from subtraction, right? If congruent segments subtracted from congruent segments, then the diffs, remember, make sure you do plural there, the differences are congruent. This problem here, I think this problem is messed up. Let's take a quick look at it. i.e., so this whole thing is congruent to this whole thing. And ETD, this angle is congruent to RID. But I think we're missing some information here. I don't think we can do this problem. I mean, we got reflexive angles, but that gives us triangle. We only have angle. We don't know that D is a midpoint. Doesn't tell us that, even though it looks like it. Can't go by that. I think there's some missing information here. I don't think we can do anything there. Excuse me. Okay, let's go to this last one. We've seen this type of diagram before, right? It's very common. So this big angle SWT congruent to STW, and then it says this little angle BTW is congruent to this little angle BWT. Now, there's multiple ways of doing this problem here, okay? We have to prove SK and these upper pieces, SK and SF. There's a lot of triangles in this figure, okay? You could prove that these lower overlapping triangles are congruent. We can do that right away. That's kind of very common. You know what? Just to be different, I'm going to prove these upper overlapping triangles congruent. And there's a reason why I'm doing that. So let's take a look. This is the triangle I'm going to do. I'm going to do this one here with its overlapping twin. Now, first, I can get this whole side congruent to that whole side, ST congruent to SW, and that's of course from if angles then sides, because we were told that the big angles opposite them were congruent. Okay. And you know what? When I see angles like this, I can get this angle here congruent to this angle here from subtraction. Angle STK, angle SWF, if congruent angles subtracted from congruent angles, then the differences are congruent. Notice how I spaced down here. I'm going to do the same thing over here, so I'm always lined up horizontally. Now, this is one reason why I wanted to do these upper triangles. You can also have a reflexive angle. You see how angle S is an angle in this triangle and also in this triangle. So now we can prove those upper triangles congruent, STK and SWF by ASA, which allows us to say that SK is congruent to SF by CPCTC. All right.